Hai semua, apa khabar? Okay, in this lesson, you will learn how to find inverse of Laplace transform by using the last properties of inverse, which is rational function. Okay, before we start, let's recall other properties of inverse. Okay, the first one is linear. We apply this property when fs has plus or minus on top of the function. Okay, for example, this one we have plus and minus. So you can separate the term into two function of s. Same like this one also, you can separate the term. Okay, for first shift, we apply this property when f function of s has s minus a or s plus a on lower part of the function. Okay, like this one. We have s minus 1 and we have s plus 1. So you can apply first shift. So today you will learn how to solve inverse Laplace transform for rational function. Okay, when fs is rational function. Before that, let's recall what is rational function. Okay, this is the definition from website Maths is Fine. Okay, rational function is a function that is the ratio of two polynomials. Okay, ratio. Tengoklah nama dia, rational function. So this is example for rational function. We have polynomial divided by polynomial. Okay, ratio of two polynomial. Okay, these are examples of rational function. Okay, if you want to find the inverse of this function, you can see that we can find it in the table. We don't have this kind of function fx in the table. So to solve rational function, you must change the function to partial fraction. Look at example A. The lower part of fs, we have linear multiply with linear. Then you can separate these two terms. And on top, you must put constant. Okay, for example B, we have linear square. S is linear and square. So you must separate the term like this. We have A over S plus B over S square plus C over S minus 3. S minus 3 is linear. Okay, so on top you put constant. Same for example C, we have linear square. So you must separate it like this. S minus 3 and S minus 3 square. Okay, for example D, we have quadratic term. If on the lower part you have quadratic form, then on top you must put linear. If lower part you have linear, then on top you put constant. Okay, you can find the values for this constant A, B, and C and so on by using the function on top of the fs. Let's look at how to find the values for this constant. Okay, for example A, on the lower part we have linear multiply with linear and you can separate into these two. Okay, look at another example. If you have 2s minus 1 and multiply with s plus 3 and you can separate it like this. On top you put constant. If you have s multiply with 2s plus 3, you can separate it like this. S and 2s plus 3. For this example, we'll separate it into these two. S plus 2 and s minus 6. So first you must multiply all the terms with the denominator, with the lower part. So okay, dua-dua kena darab dengan s plus 2 and s minus 6. And then simplify. Okay, yang ni. So we can cancel out here. We have 2s equal to as minus 6 plus b s plus 2. To find values for a and b, we have two methods. For this one, I will solve using method 1. Okay, by using calculator. have 2s equal to as minus 6a. Okay, for s, 2 equal to a plus b. Okay, and the rest equal to 0. So negative 6a plus 2b equal to 0. Okay, to solve using calculator, okay, you must rearrange the equation. A plus b equal to 2. 6a plus 2b equal to 0. Okay, guna calculator. Mode, choose 5, choose 1. Then substitute the values. Okay, substitute a equal to 1, 1, 2, and negative 6 to 0. Then you will get a equal, a is x, 1 over 2, b equal to 3 over 2. So you have changed the rational function from 2s over s plus 2 s minus 6. You have changed to a is 1 over 2 or s plus 2 plus b is 3 over 2 over s minus 6. For question B, we have linear square. Okay, s square multiply with linear. So we want to separate. So linear square, we separate it like this. S plus s square. Okay, plus s minus 3. Okay, let's solve for constant a, b, and c. Let's say we have on top of fs, we have 2s plus 1. Okay, the first step is to multiply all with the lower part of fs. Multiply with all. Okay, we can cancel out. This one will become as square s minus 3 divided by s plus so cancel 2 square s square, this one with this one. Okay, so I will solve to find values for a, b, and c using second method. For second method, okay, we let the values for s. Okay, let s equal to 3. Because when s equal to 3, this term will be 0. Because 3 minus 3 is 0. This term also 3 minus 3 0, and left with the rest. So we have 2s plus 1. To substitute s equal to 3, we will get 2, 3 plus 1 equal to, this one is 0, this one is 0. C s square is 9c. We will get 7 equal to 9c. C equal to 7 over 9. Okay, next, we let s equal to 0. Because when s equal to 0, then this term will be 0. Substitute in the function. So 2 multiplied 0 is 0. So we will get 1 equal to, this one is 0. And b negative 3 plus 0. 1 equal to negative 3b. So b equal to negative 1 over 3. Then we want to find the values for a. Okay, nilai apa yang membolehkan kita dapat jawapan A ni. Let's say we choose S equal to 1. Substitute in the values. 2 plus 1 equal to A 1 minus 3 plus B is negative 1 over 3 1 minus 3 plus C is 7 over 9. S square is 1 square. So simplify, you will get A equal to negative 7 over 9. So we have changed Fs. So Fs equal to 2s plus 1 over s square over s minus 3 equal to partial fraction. A is negative 7 over 9 divided by s plus B is negative 1 over 3 over s square plus C is 7 over 9 over s minus 3. Okay. Question C has similar function of s with question B, where we have a linear square. So when you separate the term, it will be s minus 3 and it's s minus 3 square. This one is linear. For complete answer, you can refer lecture note. For question D, we have linear multiply with quadratic function, s square plus 4. So for linear, we have s plus 2. For quadratic function, s square plus 4. On top of fs, you must put linear, bs plus c. Okay, look at this example. We have s square minus 2s plus 1. And then we separate like this. Using these values, you can find A and also B, C. Okay, the steps are the same. You multiply all with s plus 2, s square plus 4. This one multiply with this one, you will get s plus 2, we can cancel out. So A s square plus 4 plus bs plus c. This one we can cancel out with s plus 2. For this example, I will use method 1 to solve it. Expand s plus 1 equal to s square plus 4a 2c. And then compare both sides. You will get s square, as square and b s square. So 1 equal to a plus b. Okay, next we have negative 2s. We have negative 2bs, cs. This one is 2c. Okay, we have negative 2 equal to 2b plus c. The last one, 1 equal to 4a plus 2c. 1 equal to 4a plus 2c. Okay, to solve using calculator, you must rearrange the function. For the example, we have 3 variables. So you must arrange it into a plus b plus c. C is 0 equal to 1. Next we have a is 0 plus 2b plus c equal to negative 2. Last one we have 4a plus b is 0, c is 2c equal to 1. Okay, using your calculator, choose mode 5 and choose 2 because we have 3 variables. And then you will get a equal to 9 over 8, b equal to negative 1 over 8, c equal to negative 7 over 4. So this function we have changed to 4 equal to a is 9 over 8 over s plus 2 plus bs. B is negative 1 over 8s plus c is negative 7 over 4 divided by s square plus 4. Okay, before this, you only learn how to transform this function to partial fraction. So in this example, I will show you how to find inverse. Okay, how to find inverse for this function. When you see question A, you can see that we have this term on lower part. So you cannot find it in the table. But if you separate it, you can find this one in the table. This one also you can find it in the table. So you must separate the term. So equal to, we have s minus 2. S minus 2 is linear, so put constant, plus s square plus 4 is quadratic, so put linear on top. We have bs plus c. We are to solve this question. We'll get a equal to 9 over 8, b equal to negative 1 over 8, c equal to negative 7 over 4. So we have transformed fs into 9 over 8 over s minus 2 plus e is negative 1 over 8s minus 7 over 4 over s square plus 4. Okay, then you apply inverse on this function. So you want to find inverse of we have plus here, then you can separate. Okay, look at how I write the function. Okay, no need to simplify this one. Equal to, so factor out constant, 9 over 8 1 over s minus 2 plus, okay, this one. Okay, apply linear property for this function. We have negative 1 over 8s. Okay, because we have plus here, we have minus. Minus and find ft. Then we have 9 over 8 exponent to t minus 1 over 8. We have inverse of s over s square plus 2 square minus 7 over 4 inverse of 1 over s square plus 2 square. Ni boleh tengok dalam table. For this one, kita buat something lah. Kita ada, we have 2 here, so put 2 on top and divide by 2 here. So 9 over 8 exponent to t minus 1 over 8 cos 2t minus 7 over 8 sin 2t. Okay, this is the answer. So it is very important that you know how to separate this function fs to partial fraction. Okay, for question B, we have s square multiply with s minus 3. S square is linear square, so we change to s and s square. If we have s power of 3, then you change to over s plus over s square plus over s power of 3. Okay, we have solved for A, B and C. You can refer this answer in lecture note. Let's proceed to example 3. You can see that On lower part of Fs, we have quadratic form like this. When you see this type of question, you must change this quadratic to linear. Okay, let's learn how to change from quadratic to linear. Okay, before we apply partial fraction. Okay, let's say we have s squared plus s minus 30. Okay, then use your calculator. Mod 5, 3, and then substitute the values. Okay, you will get x1 equal to 5, x2 equal to negative 6. So you can change this quadratic to s minus 5 multiply with s plus 6. Okay, tengok dia punya sign dia lain, kan? This is because when s minus 5 equal to 0, so s equal to 5. This is value of s. S plus 6 equal to 0, then s equal to negative 6. This one. Okay, what if you have this type of quadratic form? 2s squared plus s minus 3. Okay, if s squared has coefficient like this, you must factor out 2. You must factor out 2 before you find the values for s. 2, okay, s squared plus s over 2 minus 3 over 2. Okay, if you check back, you will get 2s squared plus s minus 3. Then you can find s in the calculator. You will get x1 equal to 1, x2 equal to negative 3 over 2. So 2 multiply with s minus 1 multiply with s plus 3 over 2 equal to, okay, darab 2 ke dalam, you get 2s minus 2 s plus 3 over 2. So after you change to this form, this linear form, then you can apply partial fraction. Okay, let's proceed how to solve this question. Equal to 4s plus 1. Okay, then we change quadratic to linear. So s minus 5, s plus 6. Okay, then after this you change to partial fraction. We have a over s minus 5 plus s plus 6. Because it is linear, we put constant on top. And then proceed with calculation to find a and b. So we have 4s plus 1 equal to s plus 6. Okay, I will solve this example using both methods using calculator. We have 4s plus 1 equal to as plus 6a plus bs minus 5b. We have s. So a plus b equal to 4. Then and the rest 6a minus 5b equal to 1. And then use your calculator, you will get a equal to over 11, b equal to 23 over 11. Okay, let's find a and b using method 2. S plus 1 equal to a s plus 6 plus b s minus 5. And then let s equal to negative 6. So 4 multiplied with negative 6 plus 1 equal to b negative 6 minus 5. We get 23 equal to b negative 23 11. So b equal to 23 over 11. S equal to 5. We get 4, 5 plus 1. A 5 plus 6. A equal to 21 over 11. We have changed the question to want to find inverse of A is 21 over 11 divided by S minus 5 plus inverse of B is 23 over 11 S plus 6. Okay, then proceed with the answer. Okay, look at table. We have exponent 5t, 23 over 11. Okay, this one is positive 6. So we become exponent negative 6t. Okay, that's all for the last properties of inverse, which is rational function. When you say rational function, you must change the function to partial fraction. So thank you everyone. Bye.